Assalamualaikum warahmatullahi wabarakatuh. In this next occasion, I would like to present my final project research. The title of my final project proposal final project is Construction Planner and Analysis Stakeholder with Finite Element Method. Before I begin to present my final project, let me introduce myself. My name is Rafdi from Design and Manufacture Engineering. My NRP is 06, 16, 04, 00, and 33. Also, you can contact me on email at abirafdihid@student.ppns.ac.id. I think that's enough. I think that's enough for the introduction. Now I will explain the content. At first is introduction, just like I did already. The second is my final project preliminary. The third, which contain the basic theory that I will use to complete my final project to get my degree. The last will be research method, which contain the method or a step I will take to get this final project done. Now I will explain you about my background, about the background of my research. Live aircraft is one of the tools to generate profit or benefit, both financially in terms of time and its work and human activities in the fabrication process. There is an activity of lifting goods from one place to another. That matter is one of the activities that can affect the time and cost of the process production. Today's industrial world has experienced quite a lot of developments rapidly in line with increasing human needs. Industry is being should increase production output and facilitate the distribution of the product well, small in size and with a large capacity. With this encouragement, one of the companies that produce coil plate requires a lifting aid. Overhead crane is a lifting aid. Overhead crane is lifting aid moving goods located in a room. To simplify the process, lifting the coil or plate coil of the company using overhead crane with hook manifold J-hook. However, the J-hook on the company does not have a stand or storage place after use because no space for the C-hook holder while not in use, resulting in damage to the J-hook, which will be detrimental to the company if the J-hook is easily damaged. Therefore, it is necessary to hold a J-hook holder role to support the work in the workshop so that it is more efficient in processing, spatial planning, and also for J-hook maintenance. Based on the background explanation before, the problems so in this final project are as follows. Number one, how are the result of the structure analysis produced by the shareholder? Number two, how to choose the right material to make shareholder? How and number three, how to design shareholder? To get the result that our director focus on goals and problem does not extend out of the main discussion so that it can be right on the target. The problem is limited to number one is in analyzing the strength of the load, it is assumed as a static load. Second, ISO drawing standard, and the third, the author doesn't discuss and analyze the welding process. The research test for this final project is based on a research flow chart according to the method used to get maximum result, as shown below. First, problem formulation, and then field study. The third step is data collection. The fourth step is modeling. Step 5 is calculation of stress and deflection. Step 6 is simulation. Step 5, step 7 is checking the result. Step 8, analyzing the data. And step 9, RAB, or it is a calculation of the budget plan to make a shareholder, and the last is conclusions. Holder determination process, determination of length and determination of length and condition support, determination of length and condition of holder as shown on the screen. Calculation of reaction in hollow using the following calculation and get a result of 10,000, 10,718.75 Newton. Maximum bending moment is calculated using the following calculation with a result of 1071.87 Newton meters. The required cross-sectional modulus using this calculation is shown on the screen. After getting the allowable stress value, continue to calculate required cross-section. And then this is hollow determination. Then calculate the actual cross-sectional modulus using this calculation. Using the following calculation. Calculation of additional moment due to hollow weight using this calculation. After getting the value of key, then calculate the additional weight. Calculation of the modulus required using the following calculation. And then calculation of hollow tension value using the following calculation. Then the first is calculate the tension, and then calculate the shear stress. Then after that, calculate the front message stress as shown on the screen. After that, calculate the safety factor using this following calculation. Then calculate hollow deflection value using the following calculation as shown on the screen. Structure simulation. Structure simulation using Fusion 360, and this is the material specification of ASTM A36 of ASTM A63. Here is the result. Maximum force or front message stress is 180 megapascal. the deflection is 1.4 millimeters. Then the safety factor is 1.3. Okay, next. Column construction planning. This is the determination of column as you can see on the screen. And here is the calculation of load force as shown on the screen. Determining the profile to use as the table on the screen. As you can see on the screen on the table. And then before calculating the axial stress, calculate the slimness value of the column. And then calculate the column clearance slimness value. After that, compare the slimness value with the slimness value limit. And then calculate the buckling stress using the following calculation. And this following calculation is for checking column capacity. Okay. Next column, effective length. Calculate the effective length of column using the following calculation. Buckling analysis simulation using Fusion 360, and this is the material specification of ISTM A6336. This is the result. Maximum buckling displacement is 1 millimeter, as shown on the screen, as you can see. Here is the calculation and suggestion. The first, the result of von Mises stress is 192.92 megapascal, and it is still below the allowable stress, which is worth 200 megapascal. Second, and then the deflection is worth 1.51 millimeter, and still below the deflection limit, which is worth 0.66 millimeters. Buckling displacement results of 1.72 millimeter, still below the buckling displacement limit, which is worth 2.12 millimeter. In such circumstances, the construction of the CU holder is declared safe with a safety factor of 1.3. And second, based on data processing, it was found that the right material for the construction of the J-hook holder is ISTM A36. This is the detailed drawing of J-hook holder. And then the last is suggestion from the author of the effect of the actual parameters on the construction of the J-hook holder in the field, such as effect of corrosion and the histogram record of actual load, can be comprehensive supporting data for the analysis of structural strength and the result of the estimated age of the J-hook holder. Then comparing price to several workshops regarding the cost of service of or materials for making J-hook holder, so that they can optimize cost for making J-hook holders. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.